Okay, hello everyone. I am Kadir Cenk Alpay, and in this video I will talk about the first homework and I will show you the visuals with different user control parameter settings, right? So this is the initial visual. What we will do in this homework is that we will render a smooth and smoothly animated surface as a flag surface, right, with a texture image on it, and with the specular shading effect on it, I should say. Of course, our program should have two user-controlled parameters working correctly. I will talk about them in a minute. So this is the situation we have at the very beginning. This is the visual. How we will implement the homework? We first let us follow the code flow for each frame. Okay, you can see we have, for example, 60 frames per second in this video. So at each frame, at the beginning of each frame, we will, as you know, we will use Bezier surface equation, right? This is just one Bezier surface equation, and a Bezier surface equation has 16 control points. You know it. And at the beginning of each frame, we will just translate the positions of those control points of the equation, and then using the new animated control points, we will generate the new Bezier surface equation, from which we will sample the OpenGL vertices. For example, 10 by 10, in total 100 vertices uniformly distributed like in a grid. We sample from the new equation 100 OpenGL vertices, and then using those vertices we just generate the triangles of the surface in OpenGL, and this will give us the surface for that frame. So when we, for example, 60 frames per second, at each frame, when we use a smooth animation on the control points of the surface equation, and we again sample the new equation at each frame to generate the OpenGL vertices and then the triangles. At the end, we will come to a visual like this at the very end. In this visual, we have just one surface equation, one patch, okay? And from that patch, 10 by 10, 100 uniformly distributed OpenGL vertices are sampled right now. So two user control parameters are the samples. It starts with 10, which means 10 as a column and 10 as rows, in total 100 vertices. And the other user control parameter is the patches parameter. It shows, for example, for this situation, we have one patch. It is 1 by 1. If we increase the patches parameter to 2, it would become the same flag surface, would be composed of each quarter of it will be composed of one Bezier surface. In total, 2 by 2 patches, 4 patches, 4 different Bezier surface equations, and 4 times 16 control points for the whole flag surface. So we have a finer control on the animation using a higher count of control points, right? So this is the patches parameter. So let's just start with one patch here, and let's come let's decrease the samples to from 10 to 10 to 9 to 9, and 9 by 9, and 8 by 8, 7 by 7, up to down to a minimum of 2 by 2, right? Let's go to the 2 by 2 case. So this is from the Bezier surface equation, we sample 1, 2, 3, and 4. In total, 2 by 2, 4 OpenGL vertices, and generate 2 triangles from those vertices. This is the situation. And when we start to increase the samples parameter to 4 by 4, you can see 4 individual OpenGL vertices here. Those are their positions are sampled from the animated surface equation at the beginning of each frame. Okay, so 4 by 4, this is the case. By the way, this is my animation style. I just animate like horizontally. That's why all the vertices in the columns, they are animated the same, so that's why they are like edges like this. There should be if you want, you can have a vertical animation tool that would give you a more like flag surface, a different animation characteristics. It's your freedom in this homework. So this is what how I applied my animation, and this is 4x4. Let's go up to wrong parameter. Let's go up to okay. We still have one patch, and now as we increase the samples count, we get more closer to the real mathematical visual of that surface, right? More finer, more small triangles and more finer, more closer to the surface. So the second parameter, which would increase the patch size, let's increase to 2x2, in total 4 patches. Now we have a finer animation, as you can see. Each quarter of the flag is a different Bezier surface equation right now. So we have a more like finer animation, and let's increase to 3x3, in total 9 patches like this. While we are in this position, let us decrease the samples to 2x2. For each, we have in total 9 patches here. For each patch, let us have just 2x2 for vertices. We have the position we had in the beginning. So for each patch, let's have 4 points like this. This is the first patch, 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. Right? Now for each patch, we have 4x4, 16 vertices. So in total 16 times 9 vertices. This is a different setting, parameter setting. Let's increase the samples. And as you increase the samples and the patches, you can see the program starts to slow down. This is expected because we are having a much more CPU workload per frame. We recalculate the Bezier surfaces and we resample the surface using a higher vertex count for each surface. Like for example, okay, let's go a little bit higher. Okay, nearly it's frozen. Animation is very slow. So let's go back to one patch. Okay, so this is the output that we expect. What we want to see is that specular effect, the texture, those are working correctly, and the user controls are working correctly. This is the idea of the homework, and I hope you have fun while implementing it, especially using your own textures. It would be fun, I believe. And if you have any questions, you can ask them on the class, the forum of the homework. And see you.